So today we discuss your Spearman's rank correlation. So similarly, Pearsman correlation, it is same in a different way to find out the correlation between your data x and y. So this is represented by your symbol rho, and the formula for this is your 1 minus 6 summation of d square divided by n into n square minus 1. So where d is the difference, this d is here the difference between the rank of respective value of your x and y, you can say, right? So d is the difference between the pair of ranks of same individuals, means x1 y1 x2 y2, but it is not x1, it should be the rank of your x1 and rank of your y1. So it's the difference between ranks. Also n is your total number of pair we have, yeah, that is number of element we have. So the formula is simple: 1 minus 6 into summation d square divided by n into n square minus 1. So one thing, this is applicable for your univariate data only. Univariate means only single kind of the data we can apply this. Like how we can do this? Just try to understand. The 10 entries are submitted for the competition. 10 entries are here for the competition. 3 judges, like you see your Indian Idol and all these things. So these 3 judges study each entry and list the 10 in rank order. So they give some marks and then the ranks generated. So their ranking are given like this. We have the entries by the name your A, B, C, D, E, F, G, H, I, J. So J means 10, right? So we have first judge, right? So first judge give the player A as your 9th rank, B give your 3rd rank, C give your 7th rank, and D give your 5th rank, like this. Similarly, second judge also give the ranks. Third judge also give the ranks. Right. So first we try to understand this up to your 2 judges only. Right. So this is your problem. Find or calculate your approximate or appropriate rank correlation to help you answer the following questions. Which pair of judges agrees the most? So for that, agree the most means they are having the similar decisions. Similar means their correlations are very good, right? So for that, we need you to discuss the correlation for your judge 1 and 2, or between judge 1 and 2. We also need you to check the correlation between your judge 2 and 3 and judge 3rd and 1st. So we needed to here calculate 3 correlation as such, right? And the highest correlation means your decision are close to each other, right? So, and the negative means your opposite decision, right? So which pair of judges disagree the most? That means less correlation toward -1, and mostly agree means toward +1. We know that your correlation is always lies between your -1 to 1, right? So it's lies between this range. So first of all, we can discuss for your judge 1 and 2. So for we just write this in the form of your this way. So entry A, B, C, D, E, F, G, H, and ranking given by the first judge, second judge, third judge. So first we needed by the formula difference between the ranking, that is your D, right? So we require D And then we require d square, because as per requirement of formula it is summation d square is in a formula, multiply by 6 also. And we have also n into n square minus 1, and this should be 1 minus of this, and that is your rank formula. So here we need your this d, and this n is, if we, this total number are 10, so this n, capital N, or you may write small, and this is the same thing, you may write small, you may write capital, doesn't matter. So this is your 10. And now we require d. So for first, we, for just 1 and 2 we are checking, so this is row 1 2, and we calculate your d for your 1 and 2 data, that means for just first and just second. So we just take the difference between these two is 9 minus 9 is 0, 3 minus 1 is 2, 7 minus 10 is your minus 3, 5 minus 4 is your plus 1, 1 minus 3 is minus 2, 6 minus 8 is 2, 2 minus 5 is your 3, 4 minus 2 is your 2, 10 minus 7 is your 3, and 8 minus 2 is your 2. Now we require d square, that's why we just square this. So it is 0, 4, 9, 1, 4, 4, 9, 4, 9, and 4. Now we needed to add all these, because we require here d square with summation. Summation means all values additions. So you may write, add here, that's a simple one. 4 plus 9 13 plus 1 14, 14 and 4 18 plus 4 22 plus 9 31 plus 4 35 and 9 44 plus 4 40. So we just put these value in a formula, you get the value of your row, that is rank. That is your 1 minus 6 multiplied 48. That is summation d square. And divided by your 10, that is n. Then it is 10 square, that is 100, minus 1 is 99. Now just use a calculator, or you can just calculate this. This is nearly 0.71. On the same line, you can calculate your rank, or you say correlation, rank correlation between your second and third judge, and similarly your third and first judge. So for this also we can require your D23. This is D between your judge first and third, and this is D between judge second and third. So you just take the difference between 9 minus 6 is 3, and take difference between these two now. 3 minus 3 is 0, 7 minus 8 is your 1, 5 minus 2 is your 7 is your minus 2, 1 minus 2 is your minus 1, like this way, and then you can just square these values, that is 9, 0, 1, 4, 1, 4, 1, 1, 1, 4. And you just add this, that is 26. So just put in a formula, instead of your 48, we just need you to write here 26, and we can get this one like this 26. Sorry, this is just first and third. You may write here. It is 26 and divided by 990. That is n into n square minus 1. In the same way, you can check d between second and third judge and d square, and the sum is your 88 here. And once you put this in a formula, this one, that is 1 minus 6 into 88, and your 990. Just calculate these rank correlation. You calculate this is first between first and second judge it is 0.71. For first and third judge it is 0.8425, and for second and third judge it is 0.7. So it is clearly visible here the highest rank correlation is this. That means the first and third judge decision are similar to each other. Right? So we may say your first and third judge are agree most, and because of the least value, the less correlation is there. So between that is second and third judge. So that second and third judge are mostly disagree to each other. Right? So on the same way, if you can see another example, if we have the like here we say we have the data x and y, and we want to check the rank correlation between these data. So main thing that you need to take care that when you once you have rank is given, you can use directly d, that is difference between the ranks. But if your quantity is given, like numbers are given here, like x having 75, 88, 95, 70, 60, 80, 81, 50. So you must give them a rank, and it's your choice in an increasing form or even decreasing form you can consider. Like we can say it is the least value, so we can give it as your first rank, and 60 is second rank, and 70 is your third rank, right? Or you may choose the highest one as first, like 95 as first, 90, 88 is second, 81 is third, and this is your fourth rank, this is your fifth rank. So once your value is given, rank is sixth, you just convert your this value into a rank first. So we have total 8 quantity here. So here also you can convert these into rank. This is highest one is first, second, third, fourth, and I think fifth, sixth, seventh, or eighth. After that you can calculate D. So that means 5 minus 5 is 0, 2 minus 4 is your minus 2, and 1 minus 1 0, 6 minus 6 0, 7 minus 7 0, 4 minus 1 1, 3 minus 1 is 1, 8 minus 8 is 0. Now square of this, now take the square of this. So most values are 0 in this example. This is 0, 4, 0, 0, 0. We have the 1 here, 1 here, and 0 here. So if you see your sum of all these d square here is 6 only. So you just use the formula, that is 1 minus 6 into d square. D square is 6. The number of quantity we have are 8. And 8 square is 10 square, that is 64, and minus 1. Just solve this, right? And you get your rank correlation. So that is something your 0.9. So you clearly see your value is very high. So it is high degree of, as per sign, it is positive correlation. There is a positive correlation between X and Y. We may say petrol price is increasing, so parallelly your inflation is increasing, price is also increasing, petrol price is increasing, items are costly, then like this kind of the data is given to us, then we can use your correlation to check there is a relation between them or not, right? So one more thing in this rank correlation are repeated rank. Repeated rank means sometimes it happen two players got the same scores. So in that case, we can give them a tie situation, and we can give them a equal rank, right? For example, we have out of 10, your marks are suppose your 8, 7, and 7 and 6 suppose. So when you go for the ranking, this is your first ranker, and at the second position we have a tie. So what you do in this case, this one should be at a second and one should be at the third position. So in a rank Spearman rank map procedure, we just take the average of these two. So 2 plus 3 is 5, divided by 2 is 2.5. So we give the rank 2.5 to both of them. We just give the average of those positions to both of them. So obvious rank means their position. So they shared the second and third position. That's why we write here rank is 2.5. And for this one, as 3 are ahead of this, its rank should be your 4th. So you may say first, second, and third consume at these positions, and this got your 4th position. Please do not give this as your third positions, right? So these are the procedure to give the ranking. If we have the repeat, marks, score, and data is there. So what is the change in your formula? So we just needed to add one factor in your summation d square, and the factor is 1 by 12 m into m square minus 1. So m is here repetition. Repetition means in this example here, this 7 is repeated 2 times. So m here we use is your 2 only. Suppose your 5 is lies 3 times. Just suppose in the same example. So up to here we have 4th rank. So this should be 5th, 6th, and 7th position. So 5th, 6th, and 7th position. So average of these 3 positions is we add all these 3 and divide by 3 is your 6. So all these 5 share the position number 6. So this 6 is shared by 3 entries. So m is your 3 here. So we needed to add the one factor in a formula, that is your m into m square minus 1 divided by 12. So once we have the 2 entry at the tie, so we add this same factor 2 times. One for m is 2, another for m is 3. So where we needed to add, the formula is same, that is 1 minus 6 summation d square divided by, this is the formula for rank, that is n into n square minus 1. So we needed to this formula, this value m into m square minus 1 here, means with d square only in summation sum. So right, once we add this with your summation d square, if we have the multiple tie, so we can add this factor multiple time. For all m, there should be a one entry of m into m square minus 1. So this is your final formula. We may discuss this in example. So if you see here, these two, for a certain joint stock company, the price of your preference shares are given and debentures are y are given below. So if you see here, the highest value, this one, so we can give it first rank, and also your second highest is your this one, so we give second rank to this, third rank to this, fourth rank to this, fifth rank to this, sixth rank to this, seventh rank to this. Right? So we may write this in your table form. So this ranking we have done. So for these, your see your highest value is your this 99.2. So we give the first rank. This is your second highest, second rank. Third highest, we have the two positions, two same entries. So we write here this should be 3 and 4th position. So average of 3rd and 4th, or 3rd or 3 and 4 is your 3.5. We write here 3.5 at both the positions. So this consume 3rd and 4th position. Now next is your 5th position here, and 6th is here and 7th is here. So after doing this rank of your x and y's, you just calculate d and then d square. So d means your difference between these two is 7 minus 5 is 2, 1 minus 1 is 0, 4 minus 2 is 2, 6 minus 3.5 is 2.5, 5 minus 3.5 is your 1.5, and 3 minus 7 is minus 4, 2 minus 6 minus 4, and square of these is your 4, 0, 4, and 6.25, 2.25, 16, 16. Add these, we get your 48.50. As we have your ties here, and it is repeated 2 times only, so we have m is 2, multiplicity of your this rank, you see. So the factor here we may add here your m into m square minus 1 divided by 12. So this is your 2 into 2 square, 4 minus 1 is 3, so it is 2 into 4 minus 1 is 3, that is 6, or 6 by 12 is your, I think, 1 by 2, right? So we just add this in your this d square. So like this, you can just, so if you see here this one, so this is 48.5 into 6, 2 into 4 minus 1, 3 by 12, and divided by total entry as 7, so we say 7 square minus 1. So this formula, you just solve this, that is rank correlation is your 0.125, right? So this is very low and positive, so it is low degree of positive correlation between these two data. It is very low, so nearly probably no correlation, we may say, between your share prices and venture prices, right? So there is a few points that between your this on a remark on your this rank, Spearman rank. Always summation d square, not sorry, summation d, not d square. So summation d is always is 0, right? You may see in your examples, this is always 0. Also, the you can calculate rank correlation and Spearman correlation both. It's your choice, right? So both are the same kind of thing. But if you see here, this Spearman is easy to calculate as compared to your person correlation coefficient, right? And we apply this on the actual population, actual data given to us. But this we apply on your ranks only, right? Spearman one. So it is easy to apply, right? Value obtained by two formulas are slightly different to each other, right? And obviously this as this apply on direct data, the rank given by this correlation, Spearman correlation is a little give you a better result as compared to rank correlation. Rank correlation is slightly lower than your Spearman correlations. And this formula is only formula, Spearman formula is only formula we used for finding the correlation coefficient if we are dealing with your qualitative characteristic, not with your quantitative. So for the quantitative, we prefer your this Spearman's, sorry, this Spearman formula, and for the qualitative, we go for your Spearman formula. Also, Spear formula has a limitation that is not practicable in a bivariate frequency distributions, right? And also, when your n is your greater than 30, we are not use your rank correlations. So this is your rank correlations, or also called Spearman rank correlations. So thank you so much. I'm stopping here.